Number 1. The current is moving from left to right across the page, and the direction of the magnetic field lines will be from north to south, so up the page. So we take our hand, we line up our second finger in the same direction as the current, we line up our forefinger in the same direction as the magnetic field lines, so pointing up the page, and if we do that, you can see that your thumb will be pointing out of the page. So our second finger lined up with the current, our forefinger with the direction of the field lines, and our thumb points in the direction of the force or the movement of the wire, so out of the page. Number 2. This time the magnetic field lines will be pointing from left to right, north to south, across the page, and the current is going down the page. So we line up our forefinger with the magnetic field lines from north to south, our second finger with the current pointing down the page, and this time we can see that our thumb is the answer, and it is pointing out of the page, so the wire will move out of the page. Number 3. Bit tricky this one, you're going to have to contort yourself a little bit. You can see that the north pole is on this side, and the magnetic field lines will point from north to south, so from right to left. The symbol of a cross tells us that the current is moving away from us. So the current in this diagram is going into the page. My second finger needs to be pointing into the page. My forefinger is pointing from right to left, and you can see that my thumb, as a result, is pointing upwards. So number 3, the movement of the wire will be upwards. Finally, number 4. These are always the trickiest ones. They do sometimes like to draw 3-dimensional diagrams. So this is an attempt at a 3-dimensional diagram. You'll notice that also I've not got any arrows on the circuit. So how to figure out number 4. Firstly, the direction of the current. We use conventional current when we're using Fleming's left-hand rule, and conventional current flows from the positive terminal of a cell round to the negative. So the current will be flowing in this direction. So going away from us and then coming back towards us and back round the circuit. So we've got north to south. So our forefinger is pointing from left to right across the page. Now what I'd like to know the direction that this side, the left-hand side, will be forced in, and the right-hand side. So, firstly for the left-hand side, where the current is going away from us, I have north to south, left to right. The current, though, is going away from us. So I'm going to flip my hand round and point into the page, and you'll see now that my thumb is pointing downwards. So I've got left to right for my forefinger, into the page for my second finger, the current, and my thumb is pointing downwards. Therefore, this side of the motor will be forced downwards. Now you can see the current is going in the opposite direction, so you may already be able to make a prediction about which way this side of the motor will be forced, but we can double check with Fleming's left-hand rule. Left to right still for the permanent magnetic field. I've got the current coming towards us this time. Remember, it's a 3-dimensional diagram, so this is trying to show the current is coming out of the page. So if we line up our forefinger so that we're going left to right, the current is coming out of the page. Our thumb is pointing up the page. So the movement of the wire will be up the page.